SMD capacitors play a pivotal role in electronics. They consist of two conductors separated by a dielectric material, which effectively stores electrical energy. This ability to store charge is referred to as capacitance. Capacitance is quantified in farads, with common subdivisions such as microfarads, nanofarads, and picofarads. These units are crucial for categorizing the storage capacities of various capacitors. There are three primary types of capacitors: electrolytic, tantalum, and multilayer ceramic capacitors. Each type possesses unique characteristics and applications, particularly in computing environments. Electrolytic capacitors have specific codes that denote their capacitance and voltage ratings. These codes can sometimes be perplexing, but utilizing a code table can provide clarity on these specifications. Tantalum capacitors, known for their polarization, are vital in applications like computer motherboards due to their high capacitance. It's essential to understand how to interpret their codes for accurate usage. Multilayer ceramic capacitors, or MLCC, are extensively used in electronic circuits for their small capacitance needs. Their design enables them to regulate current flow effectively while preventing interference. Ceramic capacitors comprise terminals, metal electrodes, and dielectric materials. A solid understanding of these components is necessary to grasp their functionality and applications in various circuits. The coding system for ceramic capacitors includes fixed numbers, a multiplier, and tolerance. Mastering the interpretation of this code is key to selecting the appropriate capacitor for your needs. Different symbols denote polarized and non-polarized capacitors, making it crucial to recognize them in electronic schematics. This knowledge aids in correct identification and usage. Respecting the polarity of polarized capacitors is fundamental. When using a multimeter, always connect the red probe to the positive terminal and the black probe to the negative terminal. There are two primary methods for testing capacitors, using the diode option and the capacitor option on a multimeter. Each method yields valuable insights into the capacitor's functionality. While testing capacitors, pay close attention to the multimeter readings. Fluctuating readings suggest the capacitor is functional, whereas continuity or a buzzing sound may indicate a faulty component. Grasping the significance of capacitance values is critical for ensuring proper circuit operation. A capacitance code table aids in identifying the correct specifications for various capacitors. Different capacitor types, including ceramic and polarized, necessitate distinct testing methods. Understanding how to test each type guarantees accurate assessments of their condition. A healthy capacitor should disclose expected values on a multimeter, indicating it functions as intended. Conversely, if continuity or a low value is observed, the capacitor is likely damaged or defective. There are various types of capacitors, such as ceramic and electrolytic, each exhibiting unique characteristics and capacitance levels. Grasping these distinctions is essential for their appropriate application. When replacing a capacitor, it is imperative to match the capacitance value accurately while also considering the voltage rating. Additionally, the temperature rating plays a critical role in ensuring the reliability of the capacitor. Safely discharging capacitors is crucial before conducting any tests, particularly with high-voltage capacitors. Utilizing a resistor is a recommended approach for discharging them securely. The risks associated with high voltage require a cautious approach when handling capacitors. Exercising patience during the discharge process significantly reduces the chances of accidents while working with electronic components. Recognizing different capacitor types, including electrolytic capacitors, is vital for effective handling and troubleshooting. Each type typically features specific markings that indicate polarity and connection requirements. Physical indicators of capacitor failure, such as peeling skin or swelling, suggest potential overheating and imminent failure. Regular inspections can help in averting hazardous situations in electronic devices. Capacitors with high capacitance can fail by becoming short-circuited, which adversely affects their operation within the circuit board. Such failures may lead to significant issues in electronic devices. Using a multimeter in continuity mode enables users to detect short circuits effectively, indicated by a beep when continuity is established. This function aids in identifying problematic capacitors within a circuit. If a capacitor is identified as short-circuited, it could impact the entire array, necessitating a thorough examination of each capacitor. This process might involve lifting one side to ensure accurate measurement. Utilizing a multimeter effectively significantly boosts measurement accuracy. Mastering this tool is imperative for anyone engaged with electronic components and circuits. Grasping the concept of capacitance is essential in electrical applications since it directly influences circuit functionality. A solid understanding of capacitance can greatly enhance troubleshooting capabilities. Moreover, adhering to safety precautions during electronic component testing is critical. De-energizing circuits prior to measurement minimizes the risk of accidents and prevents potential damage to equipment. Capacitance values are expressed in various units such as microfarads, nanofarads, and picofarads. Understanding these conversions is crucial for their practical applications. Electrolytic capacitors are polarized and must be connected according to their markings. This ensures safe and correct operation within circuits. Ceramic capacitors utilize 3-digit codes that function similarly to resistor color codes. This system allows users to easily ascertain capacitance values through the digit and multiplier combinations. Both tantalum and aluminum electrolytic capacitors are polarized, so it is vital to pay attention to their polarity markings before installation. Conversely, ceramic SMD capacitors are non-polarized, permitting connection in any orientation. Typically, capacitors employ a 3-figure format where the first 2 digits denote significant figures and the third serves as a multiplier. Voltage ratings are communicated using alphabetic letters that correspond to specific values. Many SMD capacitors carry additional identification details, including the manufacturer's logo and batch ID. Such information is vital for tracking the component's origin and ensuring quality control during manufacturing. Manufacturing details like the date and part number are essential for ordering the correct SMD capacitors. These details specify the series type, capacitance, voltage rating, and other critical specifications. Different classes of ceramic capacitors are distinguished by color coding, which indicates their capacitance ranges and temperature characteristics. Class 1, Class 2, and Class 3 capacitors each serve unique applications. EIA codes on tantalum and ceramic capacitors offer valuable insights into capacitance values. By understanding these codes, users can easily identify and replace capacitors as needed.